Hi everyone. We are getting started with our next talk, how to build a cross-platform graphical user interface with Python. Please give Russell Keith-Magee a very warm welcome.
Oh, hi there, my name is Russell Keith-Magee, and I'm here today to show you how you can build a cross-platform GUI application using nothing but Python. Before I start, I'd like to acknowledge I am from Wajjuk Noongar Boodja, otherwise known as Perth, Western Australia. I'd like to recognise we are meeting today on the lands of the Shawnee people and to recognise their continuing connections to their lands, waters and culture, and to pay my respects to their elders past and present. But who am I? I am a member of the CPython core team and also a principal engineer in the open source group at Anaconda. Anaconda pays for me to attend conferences like this one, to talk to people like you, so I'd like to thank them for that support. They also support the Python open source ecosystem more broadly by providing direct financial support to organizations like NumFocus and by employing developers to work full-time on open source projects like Jupyter and Number, and the open source project that I founded, BeeWare. For those who haven't come across it before, BeeWare is not a single product or library or tool. It is a collection of open source tools and libraries for creating native user interfaces in Python, for desktop, but also for iOS, for Android, for single-page web apps, and for console. Each tool in the suite solves one very specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Anaconda supports BeeWare to ensure that Python remains a viable programming language on the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets, and so on. However, it is important to note that BeeWare is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. I just happen to be paid by Anaconda to work on it full time. And so, today we're going to look at how to use the BeeWare suite of tools and how you can use those tools to write and deploy a GUI app for desktop, iOS and Android, all from a pure Python code base, and how to access some of the capabilities of the hardware platforms that you're deploying on. This is going to involve two major pieces of the BeeWare suite. The first is Toga. Toga is BeeWare's cross-platform GUI toolkit. It lets you use a single code base to write a graphical user interface application that can target multiple platforms. And on each of those platforms, you get a native user interface. So on macOS, it will look like a macOS app. On iOS, it will look like an iOS app, and so on. It isn't just cosmetic appearance, though. The apps actually are native. Toga abstracts the native system widgets and capabilities, providing a common Pythonic API to build your apps. This also means you inherit all of the native capabilities of those platforms. For example, accessibility affordances like screen readers and adaptive font sizes just work. The second piece of the puzzle is BeeWare. BeeWare is Briefcase. Briefcase is a tool for packaging Python applications. It takes your Python code and wraps it up as a standalone unit that you can give to an end user with no Python experience so that they can install it on their device of choice without ever knowing that they're running Python code. In our case, we're going to use Briefcase to prepare an iOS and Android app that could be submitted to those platforms' respective app stores. Now, while it obviously pairs well with Toga, Briefcase isn't BeeWare or Toga specific. You can use Briefcase to deploy a Pygame app if you wanted to. Briefcase can't magically make Pygame work on Android, but to the extent that a GUI library supports a platform, Toga can generally support deploying to that platform. Okay, so let's dive right in. Let's write an app and then deploy it across multiple platforms. We'll start with something fairly simple, just text inputs, buttons, and dialogues. We'll add more features as we go along. So, where do we start? Well, Briefcase has a wizard you can use to bootstrap a new app. So, create a new virtual environment, install Briefcase with pip install Briefcase. With Briefcase installed, we can then run that wizard to start a new project. You run Briefcase new, you'll get presented with a list of questions with explanatory text. You'll be asked for things like a project name, your name and email, license details, and your preferred GUI framework. It's going to create an application called PyCon Demo. We're going to use Toga for this example, but there are also templates for other GUI frameworks like PySide or Pursuit by Bear. There are third-party toolkits like Pygame that provide a Briefcase plugin, or you can select an empty project with no GUI toolkit at all. When you complete the wizard, Briefcase generates the app and will give you instructions for how to run the project. So let's follow those instructions. cd PyCon demo run briefcase dev. Briefcase includes a developer mode, which lets you rapidly iterate on your app and its configuration. When you run briefcase dev, Briefcase looks at the project configuration, works out how to run the project in your local virtual environment. First time you do that, it'll install some dependencies based upon what your templated project describes, and then it will start your app. For what it's worth, Briefcase Dev is really not much more than a convenient shorthand for pip install, followed by Python -m PyCon demo, with a couple of extra flags and whatnot turned on. If all you've got is the content generated by the wizard, at this point, what you'll see is a working app. It will be an empty window, but it will be a working app. So, what has the wizard generated for us? Well, if you look in the PyCon demo folder at what's been generated, you'll find the code for your app, application icons in a variety of formats, and some project metadata. You'll get the same files regardless of what GUI framework you pick. The only difference will be the contents of app.py, done-domain.py, and some of the values in pyproject.toml and the README, plus the license file. The pyproject.toml will contain the literal answers that you've just provided to the wizard. Some of those values can be guessed, like an initial version number, plus some additional platform-specific configurations that are implied by your answers. So if we've selected Toga as our GUI toolkit, you'll get the requirements and configurations needed to support a Toga app on those platforms. All of the briefcase options are defined in the tool.briefcase sections and subsections of that configuration file. Some PEP 621 metadata is on it as well. That's the project configuration. What about the app itself? Well, the logic for the app is all contained in app.py. At the moment, it will be a bare stub. It declares a class called PyCon demo, which is a subclass of toga.app. That class has a startup method. That method creates a box, which is Toga's representation of a generic container of content. It creates a main window, sets the content of the main window to be our box, and then shows that main window. The main method for the app creates an instance of that class. And that's all the code you need to generate an empty app window that we saw before. So let's replace that startup method with some actual code that does something more interesting. In our startup method, we're going to define a static text label with the text your name. Toga lets you set the style of each widget using a subset of CSS called pack. So we tell Toga that we want this widget to have a margin around it. Then we'll define a text input so we can get some information from the user. Again, we'll give it a little bit of style. We'll mark this text input as flexible. Toga's layout is based on CSS3's flexbox, so marking the text input widget as flexible means it will be able to expand to absorb any available extra space. You'll also note that we've attached that text input widget as an attribute of self, so it's an attribute of the app itself. That's so we can access the widget later. We don't need to do that for the label because it's just static text, but we could have if we wanted to, and there are other ways to retrieve a widget from a running application. We then create a box, which is, again, the basic container widget in Toga. We tell it that it's going to have two children, the label and the text input, and indicate that it should be a row box. So all of the children should be stacked horizontally with a margin around each element. Next, we define a button with a label that says say hello and a margin, and declare that when the button is pressed, we want to invoke the say hello handler on the app. Now, that's all the widgets we need for now, so we can define our app's main box. This time, we're going to say the main box is a column box. All of its children are stacked vertically. This time, instead of declaring the children one at a time, or sorry, at time of construction, we're going to add them one by one to the existing widget. It's functionally identical to what we did with the name box. It's just a different API. So we now have a main box that is a vertical, the first child of which is a horizontal box containing a label and a name input, and underneath that will be a button. At this point, we can pick up where the old code left off, create a main window, set the content of the main window to be our main box, and then show off the main window. One piece of housekeeping that's left over, we said that when the button was pressed, we wanted to invoke the say hello handler, so we'd better declare that handler. When say hello is invoked, the first argument is the widget that has generated the event, in our case, a button. There's only one button in this application, so having the widget doesn't really help us, but if you had multiple widgets, they could all be attached to the same handler, and the widget argument could help you differentiate to know which button actually caused the event. What happens when the button is pressed? Well, we want to show a dialog to the user. That dialog will ask the text input for its current value, and then use that value as the title of the dialog. Now, you might have noticed that this is an asynchronous handler. Toga will let you use any function or coroutine as an event handler, and Toga fully integrates Python's async IO event loop with the native platform event loops used by GUI frameworks. Why would you want to use an asynchronous handler here? Well, No matter the GUI framework, no matter the platform, a GUI app boils down to a loop. That loop is essentially while not quit, process events, redraw. Now, that's pseudocode, not an actual literal API, but honestly, it is not that far from reality on most platforms. Every time you click on a button, type a character, drag the corner of a window to resize it, that's an event in your graphical user interface system. And the app code will respond to each of those events in turn, causing changes in the state and appearance of the app. Those changes in state are then reflected the next time the app is redrawn. The important detail here, though, while the app is redrawing, it's not processing events, and when it's processing events, it's not redrawing. If you've ever seen an app throw up a beach ball, this is what is happening. Your app is trying to process an event, and it's taking too long, so it hasn't redrawn in a while, for some measure of a while. And so the operating system tells you there's a problem and shows a beach ball or a little spinning icon or some visual indicator that the application has locked up. Going back to our event handler, we want to show the user a dialog, but then we want to wait until the dialog has been acknowledged. If the handler was a synchronous method, while you were waiting for the user to respond to the dialog, the app wouldn't be processing other events or redrawing. And depending upon the platform, that might even include drawing the dialog itself. By using a coroutine and awaiting the result, we can pass control back to the event loop until the user presses the OK button on the dialog. All right. So that's all the code we need for a simple GUI app that will show a dialog when the user presses a button. So let's run it. We rerun Briefcase dev again, starts the app again, and we see an app, this time with a label, a text box, and a button. The text box is flexible, so we'll expand to fill the available width. Buttons are flexible by default when they're put into a column like this, so it will as well. Type a name, press the button, and you get a dialog with whatever text is in the text input when you press that button. All right, so we've got our app running in development mode on our laptop. We'll run it now as a full app. The first step is to create the app. To do that, you invoke Briefcase create. This will do a bunch of things. First, it will look at the platform you're currently on. It will get an application template for that platform. I'm running on macOS, so it will use a macOS app template. Second, it will obtain a support package. A support package is a version of Python that can be embedded into your app. Whatever your platform, Briefcase will download a support package, unpack it into the application template that was just created. Then Briefcase downloads and installs a stub binary, a literal executable that can be used to start your app. Think of this as a copy of python.exe that has been hard-coded to just start your application. You need this so that the app appears in your operating system's task manager as PyCon-demo, not python.exe. Then Briefcase installs your application code, anything declared in the sources section of your project's configuration. It then downloads and installs your app's requirements, but it doesn't install them into your local virtual environment. It installs them into the application template. You are building an application for distribution, so you can't rely on anything that is on your computer to be on the user's computer when they actually run your application. Then Briefcase installs any application resources like icons, purges any content that you've declared as not necessary, and it's done. You've now got a complete application template. Next step, build the app with Briefcase build. What happens on this step varies from platform to platform. On macOS, it needs to sign the application binary. On Windows, it needs to write some app metadata into the executable. On Linux, it needs to actually compile the stub app for that platform. At this point, there will be a subfolder of the build folder that will contain an application along with any other files created as part of the build process. In this case, it's a macOS app. If you were to double-click on that icon, the app would start. Or you can keep it all console-based and use Briefcase, run your app with Briefcase Run. What you'll see then is a running app. It will be almost identical to what you saw with Briefcase Dev, with a couple of distinct differences. The app will present to the operating system with your formal name, so PyCon-demo in this case, rather than Python. It may also have it'll have an application icon in the toolbar. Depending upon your platform, there may be some other minor cosmetic differences. So, that's a desktop deployment. What about deploying onto mobile platforms? Well, the steps are exactly the same. You just add iOS or Android to all those commands. And again, you're done. Briefcase create iOS, Briefcase build iOS, and so on. Same for Android. iOS builds will only work on macOS because of the underlying tooling requirements, but Android builds will work on macOS, Linux, or Windows. When you run Briefcase Run iOS, Briefcase will ask, where do you want to run the code? It will look for simulators that are on your system and provide a list to choose from. If you want to shortcut that question, you can specify -D, give it an actual device to run at. But once you've picked a device, the app will start, and you'll see a mobile app that says the same layout as the desktop version, but running on a mobile device emulator on your laptop. Type some text, press the button, you'll get a dialog, again, an iOS or Android specific dialog. Briefcase can currently only target iOS simulators. Briefcase will manage the process of starting the simulator, launching the app in the simulator, and tailing the log so you can see the app run. You can deploy to physical devices, but you need to use Briefcase Open to open the Xcode project that Briefcase generates, sign up for an Apple developer account, set your developer credentials in the project, and then you can run it from inside Xcode. On Android, you can target emulators or attached devices. You need to do a little bit of a dance with the physical device to put it into developer mode, but Briefcase will try to guide you through that process. Briefcase can also target single-page web apps, text consoles, using textual as a GUI backend. I won't demo that here, but if you want details, come see me afterwards. Having validated that our application works, we can now package it for distribution. You invoke Briefcase package. Briefcase will do any final packaging needed to produce a single artifact that you can give to someone else. What that involves and what it will produce depends on the platform. On Windows, it'll produce an MSI installer. On Linux, it'll produce an RPM or a deb package. On macOS, it'll create a DMG, signing and notarizing the results. It can also produce just a bare.app bundle, or it can produce a .pkg file that you could use to distribute an app through an MDM tool. Some other features of Briefcase that are worthy of note. Although I've used the wizard to bootstrap this project, you don't have to use the wizard. You can manually write your pyproject.toml configuration from scratch, or if you've got an existing project, there is a Briefcase convert wizard that can convert that a pyproject.toml configuration into a Briefcase configuration. If you're on Linux, you can also target different distributions using Docker. You specify --target, give it the name of a Docker container, and it will use that container to build the application. Briefcase will imply earlier steps if they're needed. So if you've got a fresh project straight out of Briefcase New, running a Briefcase Run immediately, Briefcase will detect there's no template yet, generate the template, build the project, and then run the project. And Briefcase Run can also take a -u update option, so it will do an update automatically before rerunning. Briefcase Open, as I've mentioned, will open your project. If it's a simple project like a macOS app, it'll open the folder that's containing the app bundle. Or if it's an IDE-based project like iOS, that will open up the IDE on the project that's been generated. Okay, so we've got ourselves a working cross-platform GUI application. Let's add some more features. What will we add? Well, mobile devices have GPS readers. They're great at displaying maps. So let's add a map and a GPS reader to our app. Since we want to add additional features and not replace the features we already have, we're going to need some way to navigate through our app as well. So let's add a tab widget so we can switch between pages of content. So previously, we created a main box. We set the contents of our app's main window. Let's modify that a little bit and create an option container widget that contains 2 pages of content, one labeled dialog and one labeled map. We'll then set the main window's content to be our container rather than the main box. We'll then use the existing main box content on the dialog tab, and the second tab will use a map box, which we'll need to define. What's in a map box? Well, a map set as flexible, so it'll expand to fill the available space, and a button we can press to update our location. So there'll also be an event handler whenever that button is pressed. Let's put both of those into our map box, and that's our layout for our application done. Now we can define the app handler the event handler for what happens when the button or this second button is pressed. So whenever the button is pressed, let's get our current location and zoom the map to that location. Location services are governed by platform permissions, so we can't just get the location. We need to make sure we have permission to get the location first. So we request permissions from the app's location service. The location service is a hardware feature that Toga has wrapped with a cross-platform API. There's also a camera service. We'd like to add others like accelerometers and so on. Asking for permissions, we'll check that if the user has previously granted permission to the app. If they have, it'll be a no-op. If they haven't, a dialog requesting permission will be displayed. If the user has previously rejected permission or they reject permission this time, the request will fail and raise an exception. But if it succeeds, we can ask the location for a once-off location ping that'll return the location, which we can then use to set the center of the map, changing the zoom level of the map while we're at it. We could also turn on continuous location tracking, or we could drop a map pin onto the map. Toga provides APIs for both of those. There is another exception that could be raised here, not implemented. Toga currently has a map view on all desktop and mobile platforms, but it doesn't currently have an ability to do a GPS read on Windows. We can get a location on macOS, Linux, iOS, and Android. We would love to fill that gap, though. If you know how to do GPS reads with WinForms, come and get in touch. There are 2 other changes we need to make, this time to the project configuration. We can't just ask for permissions in the app. We actually need to declare that we might ask for permissions as part of the app's configuration. Briefcase has cross-platform representation for a bunch of common permissions related to location services, camera access, microphone access, and a couple of others. But there is also a mechanism for adding platform-specific permissions if you need to. In this case, we're asking for permission to know both the coarse and fine-grained location. Not all platforms differentiate between those two, but Briefcase will let you specify both and interpret those values as needed for each platform it supports. The values provided to the permissions are the text that might be displayed to the user to explain why location access is required. The text I've used here is not a good example. On macOS and iOS, for example, this text will be part of the app approval process, and your app might be rejected if it's not sufficiently illuminating in the eyes of an App Store reviewer. One last change. On macOS and iOS, Map View is available natively, but on Android we need to add a third-party package for OpenStreetMap. This is added as a Gradle dependency. The Android build process will then manage downloading the Maven package the same way that pip would download a PyPI package. So we need to add the OSM Droid line to our Android configuration. On Linux, there are also some system dependencies that need to be added. They vary depending upon the distribution. Now, because we've changed permissions and we've added a binary dependency on Android, we actually need to regenerate the app from scratch. This is a side effect of how Briefcase works and all the files that need to be modified to add permissions. When you're only changing the code of the app or adding a dependency, Briefcase has an update command or the -u option on run. However, when you change permissions or system dependencies, these properties are defined in the core project metadata that is populated when the app is created. By adding permissions and system dependencies, we need to update those files, and at present, Briefcase can't update core project configuration files in situ. That's something we'd like to fix. We've got some ideas how it could be done, but in the meantime, although it might seem a little confusing and maybe a little inconvenient, it doesn't actually impact anything in practice. You should basically be considering Briefcase's build folder to be an ephemeral product. It could be and will be deleted at any time, replaced with an updated version. You shouldn't be manually modifying files in your build folder. Your version control system shouldn't be storing artifacts in your build folder. And if you are building an app in CI, you should be using that to release your app. You should be starting from a fresh build every time you're building the app in CI. When you do run create and there's an existing build, you'll be prompted to confirm you want to delete the old project, so you're protected against mistakes and inadvertent deletion as well. And so, when the app runs, we get an app with a second tab containing a map. Press the update location button, you'll get asked for permissions, approve that permission, and the map will zoom to an updated location. In this case, we're on a simulator here, so the behavior is a simulated GPS read showing the location of the Apple campus and the Google campus on respective simulators. So the results are slightly different. So, a quick recap of what we've done in the last 20 minutes. We have created a new application. We've run that app in developer mode, which allows us to rapidly iterate on the development of the app. We've added some basic input widgets like buttons and text inputs, and we've displayed results in a dialog. We've added tab-based navigation between pages of content. We've added a map and integrated a phone's geolocation services to control the display of that map, including requesting the permissions required to generate those or to access those geolocation services. And all of this has been done entirely in Python using Python tooling and configuration files, producing an app that is completely native and entirely self-contained. Although I am a Python developer, the apps that I've generated could be uploaded to an app store or distributed on a website, and the only instructions end users would need are download and click to start. And the resulting app would be indistinguishable from an app built with Swift for iOS or with Kotlin on Android or C# on Windows. And yes, there are BeeWare applications in both the iOS and Android app stores. So, that's what we've done, but how? Surprisingly, it's actually not that difficult. Toga is based on a 3-layer architecture. The top layer, the interface, is the published API. That's what all the example code we've been looking at today does. There is a single PyPI package for that, Toga core. The interface then talks to a second standardized API called the implementation. There is an implementation for each platform that we're targeting. So there's a Toga Cocoa and a Toga iOS and a Toga Android and so on. And then there's the native layer. That's the actual platform APIs that we're invoking to display a button or whatever. As an example of how this works, take the map widget as an example. There is an interface layer, toga.mapView, that specifies that an end user can set a property named location or zoom or something like that. When you actually do that, though, the interface's value setter calls the implementation over a setLocation API. Not something you need to know about, it's an internal detail, but it does exist. How is that implemented? Well, on iOS, there's a MapView widget. It constructs an MK MapView, that's the iOS representation of a map, map. When you call set location, it uses a Python representation of an iOS MK map view instance, calls set region on that instance because that's the native API for setting the extents of a map, converts the provided location and the current zoom level to a region that will map on the display. On Android, the same layered structure exists, but it's connected to an OSM Droid map view, and it gets the OSM map view's controller, tells it to animate to a geopoint. Okay, but how does the implementation talk to the native APIs? Well, on each platform, Toga uses a language bridge to invoke native platform APIs. It's a different bridge on each platform, but these libraries allow native Objective-C, C#, Java, whatever language APIs to be invoked as if they were Python classes. Why do I tell you this? Well, first off, with a very small number of exceptions, if a native API exists for something, you can almost certainly invoke that API from Python. Secondly, if an existing Toga widget is close to what you need, but not quite, and there's a native capability that will get you the rest of the way, you can invoke that code. There is a semi-official API standard. If you call widget._impl.native on any Toga widget, you will get a direct handle to the native widget. So you can call any native API you want on that widget. And lastly, all this means that contributing to Toga, or Briefcase for that matter, isn't as hard as you might think it is. You do need to get comfortable with reading API documentation and code samples in a different language, but Java and Objective-C documentation isn't that hard to read, and you're really just looking for the nouns, the method names, so you can use those method names from Python. It is a learnable skill and doesn't require that much effort to learn the skill. Okay, so what does the future hold for BeeWare? Well, my coworker Malcolm and I are currently working on the tools for building iOS and Android wheels. As of today, PyPI will accept the upload of iOS and Android binary wheels. Pip will accept iOS and Android platform tags as inputs. CI build wheel, the next release will have support targeting iOS. Android support is in the works. So adding iOS and Android support to your favorite project on PyPI is almost at the point where project maintainers can just add iOS and Android support to their release processes. I have patches for Pillow and NumPy for iOS that I'll be submitting as soon as all the upstream dependencies have landed. Malcolm and I will be working over some other high-profile packages to land iOS and Android support over the course of this year. The other big project for this year is improving Briefcase's app packaging story, in particular improving our Windows support. We've got some plans in terms of things we want to add there. Looking longer term, there are still a handful of widgets that are needed to be added in Toga. Mobile is missing a couple of key widgets. The web and textual backends need a whole lot of extra work. Briefcase also currently stops the process of packaging the app, and we might be able to improve some of those processes. So that's cross-platform GUI development with BeeWare. If you do nothing else, I would recommend going through the BeeWare tutorial, docs.beeware.org. That gives you a complete walkthrough of all the stuff that I've spoken about today, plus more. Briefcase has plenty of configuration options and other details that I haven't gone through. If you want to know more, Briefcase's documentation is fairly thorough. I've also only touched on the very surface features of Toga. Toga's documentation contains a lot more details. The Toga GitHub repository has a lot of example code. If you like what you've seen here, you'd like to support the BeeWare project, you can join the project as a financial member. You can also back me on GitHub sponsors. That income that we use is raised to cover stickers, hosting, things like that. Like I said, I am paid by Anaconda to work on BeeWare, but the project itself is independently maintained and funded, so that financial support is important. Or if working kind is more your thing, we're always looking for new contributors. We have challenge coins for people who contribute. Come have a chat if you're interested. We'll be here for the first 3 days of the sprints. We have a Discord plus discussion forums and ticket trackers for all the projects. Details on the website beeware.org. And once I'm finished here, I'm actually heading down to the Anaconda booth to give a couple more demos about the things that I've shown here, plus a couple of other party tricks that Toga has that might be of interest if you've got a website that you want to deploy or a web user interface you want to deploy as code. Thank you all very much.